Hello, ladies and gentlemen. Thanks for joining me on today's episode where we'll be talking about the mean value theorem. Now, the mean value theorem, like the intermediate value theorem, is an existence theorem. If you recall, the intermediate value theorem was used to show the existence of an intermediate value between two y values on an interval. With the mean value theorem, we're showing the existence of a derivative on the interval that's equal to the average rate of change of the curve on the interval. So this will all make more sense as we go forward. So let's start off with a little exercise. The exercise is to sketch a differentiable curve connecting points A and B. So remember, a differentiable curve, for a curve to be differentiable, it has to be continuous and it has to be smooth. In other words, it can't have any cusps or corners. So go ahead, sketch this out, draw your point A and B, and draw your smooth curve. Now I've gone ahead and plotted in a smooth curve connecting points A and B. And I've also drawn the straight line. Why don't you go ahead and do that on your work. So connect A and B with a straight line. Now what I want you to notice is points on the curve that have the same slope as the line connecting point A and point B. So you should notice that around here, the curve has the same slope as the line, and somewhere down in here, the curve has the same slope or derivative as the line. Now, if we draw tangent lines in at the points where the derivative is the same as the slope of the line, you'll notice that it highlights the fact that the derivative at these points of tangency is going to be the same as the slope of the line. So that's the essence of the mean value theorem. If the curve is continuous and differentiable, in other words, it's continuous and smooth, then at some point along the curve, the derivative will be equal to the average rate of change, which is the slope of the line connecting the 2 points. Now here's the mean value theorem itself. If f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists a number c, an x equal to c, on our interval from x equals a to x equals b, such that the derivative at that point, the derivative of the curve at that point, is equal to the slope of the line connecting the 2 points. So that's guaranteed by the mean value theorem if our curve is continuous on the closed and differentiable on the open interval. Now here's a mean value theorem problem that you're likely to see something like somewhere along the way. We're to sketch tangent lines at the points on the function which satisfy the mean value theorem on the interval -2 to 4. So here's the graph shown with the domain of -2 to 4. And in this type of problem, the first thing you want to do is you want to connect the endpoints of the curve. So here's my line connecting the endpoints of my curve. Now you want to look for tangent lines along your curve that have the same slope as the line connecting the ends of the curve. Now I've drawn in a couple tangent lines, and you'll notice that my tangent lines have the same slope as the line that connects the endpoints of the curve. So these are the tangent lines that satisfy the mean value theorem that says that at least one point on a differentiable curve on an interval, the derivative of the curve will be equal to the slope of the line connecting the endpoints. Our next problem is, given the function 3 minus 5 over x, we need to find the value of x equals c, the value of c on the interval from x equals 1 to x equals 5. So find the value of x along the curve that satisfies the mean value theorem. So we want to find the place on the curve where the derivative is equal to the average rate of change, which is the slope of the line. So let's draw our line in first. So here's our line. Now we want to find the slope of this line. So we're going to find the slope of the line, then we're going to find the derivative of the function, and we're going to find where the derivative of the function equals that slope. So here is our calculation for our average rate of change, the slope of the line connecting the endpoints of the curve on the interval, and it's equal to 1. Next, we're going to find the derivative of our function. Now, in order to make the derivative easier, we will rewrite our f of x as 3 minus 5x to the negative 1. 3 minus 5x to the negative 1. Then we'll use the power rule, so 3 becomes 0, the 5 becomes a positive 5, and then we reduce the exponent to negative 2, so we have 5 over x squared. Next, we want to set that equal to the average rate of change and then solve for x. So we set the derivative, 5 over x squared, equal to the average rate of change on the curve on the interval. And we solve for x and we get plus or minus root 5, but only positive root 5 is on the interval. So the value of c that satisfies the mean value theorem is c equals positive root 5. And we can see the tangent line right in here. So about right there is positive root 5. So that's where the curve has a derivative equal to the average rate of change, which is the slope of the line connecting the endpoints of the interval. Hope that was helpful, and I hope you join me on the next episode. Have a great day.